In this video, we'll continue looking at problem number 9 in the sample test for chapter 2. And we're asked to give an equation of the line tangent to the graph of y equals 2x plus 3 over 3x minus 2. And I didn't write a point at which to find this tangent line, so we added this at x equals 1 in there. So the first thing that we need to do is to find the derivative. We're going to plug in x equals 1. That gives us the slope of the tangent line. So let's see how that goes. M is equal to y prime of 1. We'll just say y prime of x for right now. And that's low, 3x minus 2, d high, which is 2, minus high, 2x plus 3, d low, which is 3, all over low squared, 3x minus 2, quantity squared. At this point, we can simplify a little, or we can just go ahead and plug in 1 for x. When we plug in 1 for x, we'll get 3 minus 2, which is 1, times 2, which is 2. Plug in 3 for x, 1 for x, and we get 2 plus 3, which is 5, times 3, which is 15. So minus 15, and then over 3 minus 2, which is 1 squared, which is 1. And so we end up with negative 13 as a slope. For our point, we know that x is equal to 1. Well, what happens when we plug in 1? We'll get 2 plus 3, which is 5, over 1, and that will just be 5. So all we needed to do for this one then is to go ahead and make our equation. Y minus y1 equals m times the quantity x minus x1. We know that y sub 1 is 5, and m is negative 13, and x sub 1 is 1, and that's good enough. Just like that, we could continue if you wanted. Negative 13x plus 13 plus 5, so y would be equal to negative 13x plus 18, and that does it. Either that form or this form are fine. And that again could be verified with the graphing calculator. Just remember that when you put in that function, you need to wrap the numerator in parentheses and wrap the denominator in parentheses. So we get 2x plus 3 over quantity 3x minus 2, and we're going to zoom standard and go and take a look at that graph. At the point where x is equal to 1, we could simply go and do draw tangent 1, and there we go, negative 13 x plus 18, and you can see that clearly there. All those extra little decimals in there are just rounding error. So we'll go on to the next problem now. Alright, so let's see if we can finish off 10, 11, and 12 in this video. We have this says if tangent x minus cotangent x. This is probably a mistake here. It should say something like if y equals tangent x minus cotangent x, then what would the derivative of that be? And so the derivative is simply going to be dy dx is equal to the derivative of tangent, which is secant squared of x, minus the derivative of cotangent, which is negative cosecant squared of x. Put it all together, we get secant square of x plus cosecant square of x, and that's good enough. Alright, we'll go on to the next problem, number 10. Find dy dx when y is equal to 2x minus 7 quantity to the third power. So dy dx, or y prime, we bring down the 3, leave the inside alone, reduce the exponent to 2, then multiply by the derivative of the inside, which is going to be 6 times 2x minus 7 squared. And that does it for this one. Alright, in problem number 12, we have y is equal to cube root of 9x squared plus 4. So we'll rewrite that as 9x squared plus 4 to the 1/3 power. Taking the derivative then, we will get 1/3, leave the inside alone, get 1/3, leave the inside alone, reduce the exponent by 1, and multiply by the derivative of the inside, which would be 18x. And now the 18 divided by 3 will give you 6 there. And we can finalize this by getting 6x over 9x squared plus 4 to the 2/3 power, and that's all we need there. Alright, so we'll stop this video here and go on to problem number 13 in the next video.